Hello everyone, my name is Tomasz, and today I'm going to show you a demo of how you can use Intel Xeon CPUs and Intel Gaudi accelerators in Red Hat OpenShift AI to deploy and run a Retrieval-Augmented Generation chatbot with vLLM. Let's start with a brief introduction to what RAG is. RAG is a powerful technique that extends capabilities of large language models by combining them with external knowledge. It enables chatbot to answer queries more precisely with additional context and reduces hallucinations without needing to retrain the model. You simply upload data, which can be, for example, URL or PDF, to a vector database. Then the framework retrieves relevant chunks and supplies them as a context for generating a response. It enables the chatbot to use knowledge that was not used during training. We have modified an existing Red Hat AI Quick Start project called RAG to enable the generation pipeline on Intel Xeon CPUs and Intel Gaudi accelerators. You can use both Xeon and Gaudi to achieve maximum performance at scale for enterprise solutions. However, if you want to optimize costs, you can run the entire application using only CPU. This means you can use common cloud infrastructure without additional accelerators and still get the full experience. You will see how you can use Red Hat OpenShift AI to seamlessly deploy and manage the RAG chatbot on Intel hardware. This ensures you can balance performance and cost while using your resources efficiently. Let me show you the demo. I will ask chatbot a simple question. I'd like to find out whether Ansible Automation Platform 2.6 supports PostgreSQL 16. I'm running Llama 3.1, an 8 billion parameter model created before Ansible Automation Platform 2.6 was released. As you can see, the model lacks the knowledge to answer correctly. Sometimes it may even cause model hallucination, meaning the model generates plausible sounding but incorrect information. We address this using RAG, which retrieves relevant context before generating an answer. Instead of spending time and resources retraining the model, we can supply the specific knowledge we want the chatbot to use. I will upload the Ansible Automation Platform 2.6 release notes to a vector database and let the chatbot ingest them. Okay, I will ask the same question again, but this time I will select the vector database we have just created. As you can see, the chatbot can now accurately answer the question using newly ingested release notes. Let me show what is happening under the hood. The user interacts with the web browser UI, entering a query and adjusting parameters. The query is sent to the Llama Stack APIs, which acts as a proxy between the UI, internal RAG components, and vLLM hosting deployed model. We can expand the model's knowledge by supplying new information through the ingestion pipeline. We can upload documents, Git repositories, URLs, and other data sources. The data is then ingested by various tools and stored in the vector database. Keep in mind that if you do not select any vector database before sending a query, the chatbot will rely only on the model's built-in knowledge, which, as we saw previously, can be limited. Both RAG and the ingestion pipeline can run on either Intel Xeon CPU or Intel Gaudi accelerators. If preferred, you can use only Xeon. This design lets you optimize resource usage while running models of different sizes. Very large models can use multiple Gaudi cards when needed. If you have access to OpenShift and would like to try the RAG Quick Start yourself, go to the Red Hat Quick Start RAG repository and clone the source code. Please follow the instructions in the deploy section of README to enable RAG on your OpenShift cluster. To run the Quick Start on Gaudi, work with your cluster admin to determine what labels and taints are used to identify the HPU-enabled worker nodes. The taint key is typically habana.ai/Gaudi. It is also possible that all your worker nodes have accelerators and therefore have no distinguishing taint. If you found this demo interesting, check out Red Hat OpenShift AI resources to learn how Intel Xeon CPUs and Intel Gaudi accelerators can benefit your applications and model deployments. This demo showed that Gaudi and Xeon can efficiently run RAG workloads. Don't forget that you can run the entire stack on Xeon processors alone, without additional accelerator hardware. You will still get the full experience. You can also try more examples from the Red Hat AI Quick Starts on GitHub. Thank you for watching.